Hello, my name is John Nemoto. I am a Vice President at CGI Federal. I'm very happy to be here today to talk about using AI as a cybersecurity game changer. As a bit of a background, I'm currently working with CISA, providing a comprehensive set of cybersecurity capabilities to over 70 federal agencies, enhancing their cyber posture and protecting our nation's assets. Really happy to be here today to talk about cybersecurity and AI, but before we dive into that, I thought it would make sense to step back a little bit and talk about how cybersecurity is very similar to another disruptive technology, cloud. As you can probably recall, back in the early 2000s, cloud experienced a significant level of distrust, uncertainty, and doubt, similar to what we're seeing right now with AI as another technology disruptor. So here we have some examples of sound bites that were being tossed around about cloud at that time. Things like cloud diminishing the need for specialized IT departments and experts. They're saying we didn't need experts anymore because cloud did all these things. There was another example of outspoken CEO who made this quote about cloud, saying that I don't know what cloud is, but everybody's talking about it, and it's something that everybody does, so it's just a fashion statement. So if you fast forward to the present, with AI, I think we're seeing some very similar concerns being expressed about AI eliminating jobs and the needs for experts, and the fact that it's going to perpetuate or amplify biases that exist in information. And this all creates this lack of transparency and this certain level of distrust around AI, similar to how we had cloud back in the early 2000s. But if you see where cloud has evolved to the current state, I think we're going to see a very similar evolution of AI. So now that we've established a baseline for the perception of AI, what is the reality? Well, the reality is that AI is truly an actual cybersecurity threat. So we have to consider that. There are privacy and ethical concerns around it, and valid concerns around amplifying the existing bias in training data. These AI systems need to be transparent, and more importantly, they need to be auditable so that the outputs and the decisions that we make based on the outputs from AI are explainable at the end of the day. There's another reality that threat actors are using AI tools to rapidly identify vulnerable targets. On the program that I work on, when we introduce a new host to the internet, it is usually, we see within minutes, if not seconds, that it is being scanned by AI bots that are looking for vulnerabilities in it. We also see that there's a threat to AI models and the data sets themselves, the exposure of that information. This can result in a risk of tampering and even worse, the poisoning of that data, which further amplifies existing bias in the AI outputs. This could result in HIPAA and PII exposures, or even fines related to GDPR violations. So we've talked about some of the risks there. Now let's flip the script on this and talk about how AI can be used as a tool in cybersecurity. In the program that I'm on, I mentioned earlier that we have about 70 federal agencies that we're supporting. So for these agencies, that there are a number of tools that are being deployed for every one of them. And so you can imagine that there's a lot of data that is being produced by all of these different tools. We're bringing in endpoint telemetry information, we're bringing in vulnerability information, we're bringing now system logs. A recent example is that the gentleman in one of our programs did a test of one tool from a single endpoint that produced 4.5 gigs of uncompressed JSON data in a year. Now, if you multiply that by the number of agencies, by the number of tools, you're going to result in about several million endpoints, and you can imagine how much data we're talking about now. And the problem isn't just that that data is out there, it's that the problem now needs to be brought into a centralized repository, and we have to normalize this across all these diverse and massive data sets. And how did we do this in the past? We did it by, well, frankly, it was informed guessing that we did, or maybe even deriving it from some attributes that we knew were common across those and hoping that for the best. Well, with AI, and specifically machine learning, an example here being Amazon SageMaker, we're able to significantly increase the accuracy of asset identification and logging by using these machine learning tools. These algorithms are tuned iteratively with representative training data to improve over time. We're also able to do new and innovative things like natural language processing, where we can look at variable inconsistencies across these data sets and try to normalize them using natural language. The other reality with the use of AI and cybersecurity is that because it's cloud native now, we're not constrained to the infrastructure and hardware that we used to be. So we can process vast amounts of data in real time or near real time. And the results of that is that we are able to more rapidly identify changes in asset data quality that are happening, and it could be because maybe the SaaS tool provider made a change on their back end, that their API is no longer accessible, and maybe we have a blind spot now at those agencies, or maybe there's been a major infrastructure change that could be an indicator of some type of widespread compromise. So with these tools now, we're able to get a much more comprehensive view, not just of a single organization, but of multi-organizational security policies or postures. So as you look at where we've come with AI and cybersecurity, we started with the existing set of tools, but we have a new set of tool sets, including things like extended detection and response, XDR. Again, within this program at CISA, we provide a managed EDR function where we're looking at the alerts and incidents that are coming in from all of these tools. With XDR and AI behind it, it provides a much more holistic visibility, this comprehensive view across all these different security tools and layers and domains that we didn't have before. Before, it was a matter of oftentimes logging into a single tool for a single agency, logging out, logging into another one, and that whole sequence. Well, because we can bring this all under a single XDR tool that is being powered by AI, it gives us much better incident correlation and contextualization. We're able to understand how these incidents are spreading across different security domains and sources, enabling us to be much more faster and get a better understanding of where an attack started, the impact of it, and how it's potentially progressing, not just within a single organization, but potentially across multiple ones. And we're not just waiting for these things to happen. With AI, we're able to use things like machine learning algorithms that are able to predict where there are potential security events by analyzing the historical data and looking at trends. It's really not just waiting for specific patterns that it's observed before. So we can look for and detect on potential unknown zero-day threats by recognizing where malicious behavior that is deviating from the norm and not just looking for known patterns. And we're not just looking at the systems themselves, but also these AI-driven tools are able to look at user behavior. So to identify where there might be suspicious activities, such as unusual login times, or maybe impossible travel events, or access to some unauthorized resources that they normally wouldn't be accessing. This helps to identify and prevent insider threat. So we've talked about using these AI tools externally as part of our cybersecurity tool sets. Now we want to look internally at how we can use them as well. And this area is specifically around DevOps, pipelines, and development environments. With this continuous development, integration, deployment, it doesn't mean that we're immune to security flaws. Because of the fact that now we have independent teams that are generating simultaneous changes to code at the same time and potentially modifying configurations on the fly, the potential there for malicious code injections that could be deliberate or accidental, but that could get lost in the shuffle because you have teams that are making simultaneous changes and operating independently. We also have to make sure that we're staying compliant, right? That we are following regulatory standards, and that maybe the potential for supply chain risk because we're inserting code from an external source, that can become secondary in the CI/CD just-in-time release model. So there are tools out there like Code Whisperer, Amazon Code Whisperer, that use AI on the back end to automate code review and vulnerability detection, really looking for patterns there where we could potentially be inserting vulnerabilities or bugs or even coding errors that could create a future vulnerability. It's very important to maintain those configurations, and these tools help to maintain them against certain standards and policies, and not just maintain them, but enforce any configuration drift that happens over time. And finally, these pipelines are being monitored by these tools for unauthorized changes, and we want to make sure that only approved code and configurations are being deployed, and that we can detect and block malicious code injections during that build process before they make it into your final build. So we've talked a lot about what AI can provide, but kind of to take it back to the original, what I talked about at the beginning of this presentation. There's a human element to this that we need to understand, and that AI needs to be, at the end of the day, properly trained to be an ethical and effective cybersecurity tool. We have to ensure that AI systems are trained ethically and aren't perpetuating or amplifying biases. A good example is I was recently talking to a colleague of mine who's an expert in large language models, and he mentioned that, reminded me that large language models are incentivized to succeed, right? They are going to continue to adjust their response based on the prompts and the feedback that they're getting. But you need to make sure that you're looking at their responses objectively and as you're validating the outputs of these AI tools. The models also need large amounts of data that is properly labeled and annotated. And this is really critical in those machine learning models we talked about earlier, because it provides the necessary context for the AI to really understand and learn and improve. And without that, it's just going to continue to repeat and provide potentially invalid results. And finally, humans have to validate those results produced by the AI to ensure the accuracy and reliability of them. It's important to have this continuous feedback because that's what's going to help the model improve over time. And so to summarize, I think today we've talked about how AI does present unfamiliar risks and challenges, but it's also an incredible opportunity to revolutionize the cybersecurity landscape. And despite this automation that we talked about and all the promise of AI, it's important to understand that humans will always be critical to the effective and ethical adoption of this new and disruptive technology. Thank you.